So today we will start the condition for maxima and minima. Okay, condition for maxima and minima. Silent recording. Intensity distribution for double slit. Double slit diffraction pattern. Double slit diffraction pattern. Okay. Number one, condition for central maxima. Number one, condition for central maxima. Okay. We know the intensity distribution. We know the intensity distribution for the. We know the intensity distribution for the double slit diffraction pattern. For the double slit diffraction pattern is double slit diffraction pattern is, what is the intensity distribution? মনে আছে? কালকে যে পড়লাম I equals to 4I0 sin square beta by beta square into cos square gamma. Equation 1. Okay. When theta equals to 0, when theta equals to 0, then beta equals to zero. What is beta? Pi by lambda p sin theta equals to 0. Okay, and gamma equals to pi by lambda a plus b sin theta, which is again equals to 0. Okay, gamma equals to 0. But like a single slit, if beta equals to 0, then what happens? It becomes infinity. Okay, so why beta not equals to 0? We have to take beta tends to 0. Okay, later. Therefore, limit beta tends to 0, sin beta by beta equals to 1. Limit beta tends to 0, sin beta by beta equals to 1. Okay, when beta tends to 0, that is beta tends to 0. And when gamma equals to 0, if gamma equals to 0 and cos gamma equals to 1. Okay. As gamma equals to 0, so cos gamma equals to 1. Okay. Therefore, the intensity of the central maximum. Therefore, the intensity of the central maximum is. Therefore, the intensity of the central maximum is. Here we have sin theta if it equals to 1, cos gamma 1 হয়ে গেছে. Okay, when তোমার theta tends to 0, when theta tends to 0, cos gamma is 1 and limit theta tends to 0, sin theta if it equals to 1. Okay, that means r equals to 4i0. Intensity is r equals to 4i0. Intensity of the central maximum is I equals to 4i0. Comma দিয়ে লেখো, comma দিয়ে, which is 4 times the intensity of the central maximum. Okay, which is 4 times the intensity of the central maximum for the single slit. Because in case of single slit, we see that the intensity of the central maximum was I equals to I0. Okay, here we get I equals to 4I0. So the intensity for the double slit, intensity of the central maxima for the double slit is 4 times that of the intensity of the single slit. Okay. Number 2, condition for minima. Number 2, condition for minima. Condition for minima. For diffraction minima, the intensity is 0. For diffraction minima, the intensity is 0 when sin beta equals to 0 but beta not equals to 0. For diffraction minima, the intensity is 0 when sin beta equals to 0 but beta not equals to 0. Why? In yesterday we have written that this is the term for the diffraction. Okay, first one is for the diffraction and the second one is for the interference. Okay, so for the diffraction what happens? Sin beta equals to 0 but beta not equals to 0. Sin beta equals to 0 but beta not equals to 0. Sin beta equals to 0 but beta not equals to 0. Okay, so when sin beta equals to 0 but beta not equals to 0, if beta equals to plus minus m5, okay, that is beta equals to plus minus m5, where m equals to not 0, m equals to 1, 2, 3, etc. If m equals to 0, then beta becomes 0. If m equals to 0, then beta becomes 0. So what's happened? Beta equals to plus minus m5, m equals to 1, 2, 3, etc. not 0. Okay? What we know beta equals to? Or beta equals to which pi by lambda b sin theta equals to plus minus m5, or b sin theta equals to plus minus m lambda. So this is the condition for diffraction minima. This is the condition for diffraction minima. This is the condition for diffraction minima. For interference minima, for interference minima, for interference minima, here this is the for interference. This cos gamma equals to 0. So when cos gamma equals to 0, then there is the interference minima. So if cos gamma equals to 0, then what is gamma? Therefore, gamma equals to 2n plus minus 1 into pi by 2. Gamma equals to plus 1. 2n plus 1 pi by 2. Why? So when n equals to 0, then it is pi by 2. Cos pi by 2 is 0. Okay. So when n equals to 1, it is 3 pi by 2. Cos 3 pi by 2 again 0. So this is the pi by 2. Or what is gamma? Gamma equals to 2 gamma 0 2 pi by lambda. So gamma equals to pi by lambda a plus b sin theta equals to 2n plus 1 pi by 2. Okay? Or a plus b sin theta, a plus b sin theta equals to 2n plus 1 lambda by 2. Okay? A plus b sin theta equals to 2n plus 1 lambda by 2. Okay. So this is the condition for interference minima. This is the condition for interference minima. I don't know. This is the condition for interference minima. Now we have to go for the condition for maxima. That is the secondary maxima.
This is the condition.
Now the condition number 3. Condition for only maxima. That is the secondary maxima. Condition for maxima. देखो condition for maxima. देखो the interference maxima occurs. The interference maxima occurs when cos gamma equals to 1. The interference maxima occurs when cos gamma equals to 1 or gamma equals to what? 0 তারপরে 0 পরে 180 360 like that. That means 10 pi. cos square gamma আছে in the intensity expression there is a cos square gamma, so it will again minus 1 and minus plus, so gamma equals to plus n pi, gamma equals to n pi, where n equals to 0 1 2 3 etc. now. Okay, here now n equals to 0. Okay, or again gamma equals to pi by lambda a plus b sin theta equals to plus minus n pi, or a plus b sin theta equals to n lambda. So this is the condition for interference maxima. This is the condition for interference maxima. Okay? Now right. So in the double slit pattern. So in the double slit, this is the condition for interference maxima. This is the condition for interference maxima. Okay. In the next para. So in the double slit pattern. So in the double slit pattern. So in the double slit pattern, there will be a number of alternate dark and bright interference fringes within each diffraction pattern. That means so as I told you, if this is the diffraction pattern, this is the diffraction pattern. Okay, so inside this diffraction pattern, there is a number of interference bright and dark fringes. Okay. So this is the diffraction pattern. And this is the interference pattern. So we can see that inside the diffraction pattern there is so many interference bright and dark fringes. Within one diffraction pattern there is so many interference bright and dark fringes. Okay. Now what happened? Now we go for the missing order. The missing order of interference missing order of interference maxima. Missing order of interference maxima. Okay. What is our? So what is missing order? Missing order means if we cannot see any maxima, then that is called a missing in that pattern. Like here, what happened? It is the diffraction minima, and here there is another interference maxima. Okay, but we don't draw it here. Why? Because this is the missing order. Because the dark fringe of the diffraction is superimposed in the bright fringe of the interference. So what happened? We cannot see that interference maxima at that point. That is called the missing order of the interference maxima. So what is the condition? There must be some condition. Now we find out that condition for missing order. Let's go. Start. If the slit width B is kept constant, if the slit width B is kept constant, kept KEPT is kept constant, and the width of the opaque space and the width of the opaque space OPAQUE, opaque space A, small a, width of the opaque space A is gradually alternate. Opaque space A is gradually alternate. Then according to the condition of diffraction minima. So what is A and what is B? Okay, draw korichilam. This is the B, right? Slit width B, and this is the opaque space A. This is B and this is A. So what happened? This slit width remain constant B. Now we change this A. We can change this A. That is the distance between the slit increases or decreases. Okay. If we change the distance between the slits, that is, if we alter the value of A, then what happens? Condition of diffraction minima. B sin theta equals to plus minus m lambda. B sin theta equals to plus minus m lambda. Number 1. So you can see that if B is constant, then theta is also constant. That means this condition remains same. Okay. So the diffraction pattern. Remains unaltered. So the diffraction pattern remains unaltered. So the diffraction pattern remains unaltered. Altered. Then according to the condition of diffraction minima. B sin theta equals to plus minus m lambda. So the diffraction pattern will remain unaltered. But according to the condition of interference maxima, condition of so the diffraction pattern remain unaltered. Okay, but according to the condition of interference maxima. What is the condition for interference maxima? But according to the condition of interference maxima, A plus B sin theta equals to plus minus n lambda. Equation 2. So here you can see that B is constant but A is changing. So what happens? This condition also changes. Okay, that means what happens? This position of the bright and dark fringe will change. If we change the value of A, then the position of the interference bright and dark fringes will be changed. Okay, but the diffraction pattern remains the same. Okay, look. So the spacing between the interference maxima. So the spacing between the interference maxima. So the spacing between interference maxima changes. So the spacing between interference maxima changes. Okay, that means this is the interference maxima. This is the interference maxima. So this space between the interference maxima will change. Okay. Then what happens? Therefore, it may so happen that for a particular value of angle of diffraction theta, for a particular value of angle of diffraction theta, for a particular value of angle of diffraction theta, the conditions of interference maximum and diffraction minimum. The condition for interference maximum and diffraction minimum are simultaneously satisfied, and diffraction minimum are simultaneously satisfied. Therefore, it may so happen that for a particular value of angle of diffraction theta, the conditions of interference maximum and diffraction minimum are simultaneously satisfied. Okay, then the corresponding interference maximum will be missed. Then the corresponding interference maximum will be missed. MISSED will be missed from the resultant spectrum. The corresponding interference maximum will be missed from the resultant spectrum. Okay? So for a particular value of theta, So for a particular value of theta, from equation 1 and 2 we get, so for a particular value of theta from equation 1 and 2 we get, if we divide 2 by 1, divide equation 2 by equation 1, here a plus b by b equals to n by m. A plus b by b equals to n by m. Okay, equation number 3. This is the condition for missing order. 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 Okay, so what's happened here? Now we have to find out for the first order, second order, like that. Okay, what's happened? For the first order, কি হবে? দেখো number 1, case 1. Don't talk. Case 1. So when A equals to B, when A equals to B, why? Because B is constant, we change the value of A. So at a certain time it may occur that A equals to B. Then what's happened? If A equals to B, then A plus A, that is 2A by A. Okay, that is 2. Then from equation 3, when A equals to B, then from equation 3 we get 2 equals to n by m, or n equals to 2m, or n equals to 2m. Okay, so what's happened? We know that m not equals to 0. Okay, so m equals to 1, 2, 3, etc. Okay, therefore it is equals to 2, 4, 6, like that. Okay, so what is n? N is the condition for interference maxima. That is the order of the interference maxima, n. So what happens? From here you can see that when A equals to B, then n equals to 2, 4, 6. These maxima will be missing. These maxima will be missing when A equals to B. Okay, let's go. So the second, fourth, sixth. So second, fourth, sixth. Dot of these away. So second, fourth, second comma, fourth comma, sixth comma, dot করে দাও. Order interference maxima, second, fourth, sixth order interference maxima will be absent. Will be absent as they will coincide with first, second, third. They will coincide with first, second, third order diffraction minima. Okay, why? M is the condition for diffraction minima. Right? M is for the condition for diffraction minima. So when M equals to 1, 2, 3, then M equals to 2, 6, 4. So n equals to 1, that means this one. Okay, diffraction minimum, first order. Here what's happened? Second order maxima. Second order maxima of the interference will coincide. It is like that. So what happened? We cannot see this maxima. That is called the missing order. Okay? Number 2, case 2. Case 2. When A equals to 2B. Case 2. When A equals to 2B. Okay, that means the distance between the slit is double that of the slit width. Okay, when A equals to 2B. Then N equals to A equals to 2B, that is 3, right? B equals to N by M, multiplication 3, or N equals to 3M. So that is it is 3, 6, 9, dot, dot, dot. So when M equals to 1, 2, 3, then N equals to 3, 6, 9. That means your third, 6, 9th order interference maxima will be missing. Okay? Lekho. When A equals to 2B, when A equals to 2B, then the third, 6th, 9th, third, 6th, 9th, dot দিয়ে দাও order interference maxima, third, 6th, 9th order interference maxima will be missing as they will coincide with the missing, as they will coincide with the first, second, third order diffraction minima. First, second, third order diffraction minima. Okay. So today is up to this one. In the next class, we'll start the transmission grating. That is the N slit. Okay. Here it is second slit, double slit, first slit, single slit, double slit. Then we go for the N slit. That is the grating.